Welcome to qnawire.
So here in this problem we have to find the time interval delta t which is required for the ice thickness to increase from 4 centimeter to 8 centimeter, and we are given that the temperature of the ice is 0 degrees Celsius and the ambient temperature is minus 10 degrees Celsius. Now we know that the rate of change of heat dq by dt is equals to Ka delta T by x, where K is the thermal conductivity, A is the area, and delta T is the change in temperature, and x is the thickness. Now that dq incremental energy is equals to L times rho times area dx. So here L is the latent heat, rho is the density, and A is the area. So you can plug this value here. So we'll get L times rho A dx divided by dt is equals to Ka delta T by x. Now A and A will cancel out both the side, and we can take dt this side and x this side. So we'll get L times rho, and it's x dx is equals to K delta T dt. Now we're going to integrate both the side. Since L and rho is a constant, we can take it outside the integration, and here also K and delta T we can take outside the integration because K is constant and the change in temperature here delta T is 0 minus 10 degrees Celsius. So we'll get 10 degrees Celsius, which is constant, so we can take outside the integration, and we want that thickness should increase from 4 centimeter to 8 centimeter. No need to write units, and the time is, we have to calculate it. When the time is 0 second, the thickness is 4 centimeter, and when the time reaches to delta T, the thickness should become 8 centimeter. From here we get L times rho x square divided by 2, and here the limit is from 4 to 8, and it's equal to K delta T, and the integration of dt will be T, and when we plug the units we'll get delta T. Don't confuse between delta T and delta T. This delta capital T is the change in temperature, and this is for change in time. So now we can plug the values here. We know that the latent heat for ice is 3.33 into 10 to the power 5 joule per kg, and density we know it's 917 kg per meter cube. And now we're going to plug the units, this limit. So 1 by 2 we can take outside, and we know that the limit is in centimeters, we have to take in meters. So if we convert into meter, we'll get 0.08 whole square minus 0.04 whole square, and this is equals to K, that is the thermal conductivity, and thermal conductivity of ice is 2 watt per meter degree Celsius, times delta T we have calculated it as 10 degrees Celsius, and this small delta T we have to calculate. From here delta T comes out to be as 10 point, it's, let me write in seconds, 3.66 into 10 to the power 4 second. If we convert into hours, we'll get approximately 10.2 hours. So in the end we can conclude that the time required is 10.2 hours. So I hope you got the problem. Thank you.